we have question number 46 now. A compound with molecular formula 450, so it contains CHNN only, is acetylated with acetic anhydride to get a compound with a molecular mass 828. The number of amine groups present per molecule of the former compound is. Okay, so students, if we talk about the acetylation of amines, so we have RNH2. When it is allowed to react with acetic anhydride, so we have AC2O. Okay, so we have the formation of RNHCOCH3. Students, we can clearly see that there is addition of a COCH2 group due to acetylation. Okay, so when this is added, students, it will lead to an increase in the molar mass by 42 units. Okay, so if we talk about the given amine, students, its molecular mass was 450. If we assume that there are n number of amine groups, so 450 plus n into 42 should be equal to 828. So this is the conservation of mass, students. If we talk about the value of n, it is going to be 828 minus 450 upon 42. So this on simplification gives us a value equal to 9. Okay, so the number of amine groups present per molecule of the former compound is equal to 9. So students, for this question we have to mark the correct answer as 09. Let us look at the next question now. Question number 47. How many chiral compounds are possible on dichlorination of 2-methylpropane? Okay, so if you look at 2-methylpropane, students, so this is 2-methylpropane. And if you talk about the dichloro product, students, we can have a case in which both the Cl are added on the same carbon, which is the terminal carbon. Okay, we can have a case in which one of the Cl is added at the tertiary carbon while the other is added at the terminal carbon. Okay, we can have another case in which both the chlorine atoms are added on the terminal carbons. Okay, so there are these three possibilities, students, and if you look at these compound, students, none of them are optically active, none of them are chiral. So students, for this question we have to mark the correct answer as 0. Okay, it forms three compounds, none of which are chiral. Let's look at the next question now. Question number 48. For the estimation of nitrogen, 1.4 gram of an organic compound was digested by the Geldal method and the evolved ammonia was absorbed by 120 ml of M by 20 H2SO4. The unreacted acid required 40 ml of M by 20 NaOH for complete neutralization. We have to comment on the percentage of nitrogen in the given compound. Okay, so we can first have the acid-base neutralization, students. So if we talk about the acid-base reaction or the acid-base neutralization, we have MEQ of H2SO4 equal to MEQ of ammonia plus MEQ of NaOH. Okay, so if we talk about H2SO4, students, we have 120 ml and M by 20 H2SO4. So we have 120 into 1 by 20 into 2. Okay, so MEQ of ammonia we have to find out. And if you talk about the MEQ of NaOH, students, the MEQ of NaOH is 40 into 1 by 20. Okay, so this gives us a value equal to 12. And MEQ of ammonia plus the MEQ of NaOH, it will be equal to 2. So we can clearly see that the number of milliequivalents of ammonia is equal to 10, which is also the number of millimoles. Okay, so we have 10 millimoles of ammonia, which means that there is 10 millimole of nitrogen also by conservation of mass or the POAC. So we have 10 millimoles of nitrogen. If we talk about the mass, so 10 into 10 to the power minus 3 into 14. So this is the mass of nitrogen in the given compound. The total mass of the compound taken was 1.4 grams. And if you talk about the percentage, this has to be multiplied by 100. So we can clearly see that this on simplification gives us a value equal to 10. So nitrogen is present in an amount of 10% in the given compound. Okay, so students, for this question we have to mark the answer as 10 Let us look at the next question now. Question number 49. So we have been given a polymer and it is told to us that this is the polymer of but XII YOL. So the IUPAC name of the monomer is given to us. We have to comment on the value of X by Y. Students, if you look at this given polymer, students, we can clearly see that its monomer must have been this compound, and this must have polymerized by the addition polymerization or the free radical polymerization. So this, when it is allowed to polymerize, it is going to give us this polymer. Okay, so if you look at its IUPAC name, students, it is going to be but 2 in 1 all. So the value of X is equal to 2 and the value of Y is equal to 1. And if we talk about the ratio of X's to Y, we are going to have a value equal to 2. Okay. So for question number 49, we have to mark the answer as 0, 2. Let us look at the last question, students. Question number 50. An organic compound O, so it is C3H8O, when oxidized by using Jones reagent gives us an acid P. So students, the compound O has to be a primary alcohol. So the primary alcohol, when oxidized using Jones reagent, it gives us the carboxylic acid P. Okay. P on further reaction with ammonia gives us Q. So when it is allowed to react with ammonia, students, it gives us the ammonium salt of the carboxylic acid. So we have CH3, CH2, COONH4. Okay. So this is the compound Q. It is further mentioned to us that on heating Q gives R. So when this salt is heated, it gives us an amide. So we're going to have CH3, CH2, CONH2, which is propanamide. So this is R, students. It is further mentioned to us that R reacts with Br2 in presence of KOH to give an amine. So when this amide reacts with Br2 KOH, it undergoes Hofmann degradation to give us CH3, CH2, NH2. Okay. So this is the final amine which is formed, students. It has a molar mass of M. So we have to comment on the value of M. So if we talk about the molar mass of this amine, students, we have 15 plus 14 plus 16. So its molar mass is going to be equal to 45. So students, for question number 50, we have to mark the correct answer as 45. This is it for today, guys. I hope the solutions were clear to you. Thank you.